All right, so like I said yesterday, when we solve inequalities, it's pretty much the exact same thing that we did when we solved equations with the equal signs in the middle. Inequalities are just like equations. You can manipulate each side of an inequality as long as you perform the same operation on both sides of the inequality symbol, right? This is exactly like equations. Just imagine that there's an equal sign in there instead. Same thing. The only difference, there is one thing we have to watch out for, and that is if you multiply or divide each side of an inequality by a negative number, we have a special rule. And that is that you must flip the inequality symbol to face the other direction. This is only happening if we are dividing by a negative number or multiplying by a negative number on each side of the inequality. So if I'm like distributing on one side a negative number, that doesn't count. Has to be done to both sides. Questions on that? We're going to see that happen in a second. Let's go through some of these examples. For example 1A, I'm literally going to pretend that this has an equal sign in the middle. I'm going to draw my railroad track through the center of it. And I'm going to use inverse operations, right? Reverse order of operations, backwards GEMDAS. If I have n minus 5 to get rid of a minus 5, I do the opposite, plus 5 on both sides. So I'm left with n is less than 2. That is my inequality, and I'm going to graph that. Remember, when we graph our inequalities, we need 3 numbers on our number line. We're going to put that 2 smack dab in the middle, and then I'm going to pick one number lower and one number higher than that. N is less than 2. Does that get an open or a closed circle? Perfect. And then less than 2, does that point to the left or to the right? Give me a finger. Point. It's going to go to the left. All the numbers that are smaller than 2 go to the left. All the numbers that are bigger than 2 go to the right. Perfect. Any questions on that? Nice and easy. Nothing crazy here. Okay, look at B. Now we're doing multi-step. It does not change from what we did when we did multi-step equations. The only thing that's different is that inequality symbol and that we have to watch out for dividing by negatives. My first step here should be what? Subtract that 13. Remember there's like an invisible plus sign in front of there? So we start with backwards GEMDAS, SAD-MEG, addition and subtraction first. This is 2v is greater than negative 24. Then I'm going to finish it off. I'm going to divide both sides by 2 to give v is greater than negative 12. Do I need to flip my sign here? I divided a negative number. Isn't that my rule says? Did I divide by a negative number? No, the thing that I divided by was positive. So I don't need to flip my sign here. So maybe this is one that you put a little star at, like, hey, look at this. There was a negative, but I didn't divide by a negative, so my sign stayed the same. All right, I put negative 12 in the middle. One number smaller, one number bigger. Open or close circle. Pointing to the left or to the right? I want the numbers greater than negative 12. V is greater than negative 12, so that points in the positive direction, right? Positive always to the right. Okay, perfect. Any questions on that? Let's keep going. Letter C. What's my first step? I got to get n by itself. What do I do? What's the inverse operation here? Yeah, it's n divided by negative 3, so I need to multiply by negative 3. What do I need to watch out for? I just multiplied by a negative number on both sides, so my sign, I have negative 1 times negative 3 is a positive 3, and instead of my sign facing this way, now my sign's going to face this way. I'm just literally flipping it. That's it. That's the only difference between solving an equation and solving an inequality. So the easiest way to graph these is if we remember to always keep our variable on the left side. So really I should flip this around. Remember, when I flip it around to put the variable on the left side, we just want to make sure that my Pac-Man mouth is still facing the same way. So if the Pac-Man mouth is facing this N, when I flip it around, the Pac-Man mouth should still face that N. You do not have to do this. You can still graph these without flipping it, but it's easier to see when we do that. So this says N is greater than 3. I'm going to put 3 in the center. I'm going to pick a number that's smaller and a number that's bigger. Open circle or closed circle? N is greater than 3. Open or closed? Open. Left or right? We're going to face to the right. We have N is greater than 3. Perfect. Questions there? So this one we did flip our sign. Maybe make a note for yourself for the future. And then letter D. What is my first step for solving letter D? Same as it would be if this was an equation. Read. Perfect. I'm going to distribute that -2 to both of those pieces. 10 is less than or equal to -2 times 4m is -8m. -2 times +7 is -14. I'm seeing a lot of mistakes on our tests that are literally just forgetting our negatives in different places. Make sure that we're paying attention to those negatives. They're tricky. Okay, Miss Lise, I just multiplied by a negative number. Do I have to flip the sign? What do we think? Why don't I flip the sign? Yeah, I only multiplied that -2 on the right side. I didn't do anything to the left side. Remember that we only flip the sign if we are multiplying or dividing by a negative number on both sides, which I have not done yet. So let's continue solving. Maybe I will later on. So I'm going to add 14 to get 24 is less than or equal to -8m. I'm going to keep going. I divide by -8. Hey, Miss Lise, do we flip the sign now? Yeah. Now I'm dividing by a -8 on both sides. So this becomes -3. I flip my sign to face the other way. And then there's my m. Now, this is fine. We can graph this. And this doesn't happen every time. It just happened to happen in these two examples. But the m is on the right side. I'm going to flip the whole thing around to make it on the left side again. My alligator mouth is facing the -3, so I just want to make sure that it also faces the -3. This does not happen every single time we have a divide by or multiply by a negative number. It just happened to be in these two examples. So let's finish it off by graphing. I have m is less than or equal to -3. -3 goes in the center. I pick a number bigger and a number smaller. Open or closed circle here? Closed because of that equal sign. This guy right here, facing to the left or to the right. Less than or equal to -3. Those are my more negative numbers, so this should face to the left. Is it? No, yeah, because we switched it around. Yes, that's why we switch things. All right, any questions on these? We feel like we got it? We see the rule happening here? Okay. All right, flip it over. I don't want to do all of these, but I think I want to do... Can we skip A? I feel like that one's so easy. Can we just do B and C? Go ahead and try B and C. And if you feel like you want to do one... Oh, we already have 2 volunteers. Here we go. I don't know what the actual answers are. Hold on. Yeah. Beautiful. Do you remember to flip your sign here? I don't think you did. Not there. So you flipped it to face the 3, and then you flip it again when you rotate your equation around. Perfect. All right, any questions on these? I'm going to walk us through one word problem, and then I will let you go. Okay? All right. Should it be 8? For letter C? Oh, this should be 8. Yes, it should be. So then that's... Yes, that's 3. So this is 9 over 2. Okay, that just changes these values. It doesn't really change what our graph looks like. 9 halves is like 4.5, so this should be like a 5 and a 4 instead. We can use whole numbers. We don't have to worry about decimals or fractions in our graphs. Good catch. All right, any questions on those? All right. We're going to now write our inequality statement. We're going to do basically the exact same thing that we did with equations. We're going to define our variable. We're going to look for totals. We're going to look for those words, those keywords we talked about in Unit 1. You decide to run to the grocery store with your mom. You want bags of chips that are $3 each. Your mom already has $60 worth of groceries in the cart. Your mom wants to spend no more than $80. What are the possible numbers of bags of chips that you can buy? What is the question asking us to find? What's our variable? Read. Number of bags of chips. Let's call it X. The first thing that we should do is now look for a total. What's the total value in this equation? 80. We have $80 to spend. I'm going to put that on the right side. I want to spend no more than $80. So let's assume that the rest of my equation is over here, and I'm putting an inequality symbol in there. What inequality symbol is no more than? Autumn? Less than or equal to. It can equal 80. We can't go over 80. So I want less than or equal to. Perfect. Now what goes on that left side there? I need my variable in there somewhere. Read. Perfect. 3 times X. We see that word each. $3 each bag. Plus the extra $60 that she already has in the cart. There's my inequality. Any questions on that? Okay, let's solve it up. Minus 60 on both sides. I have 3x is less than or equal to 20. We're not going to get a super nice number here. I believe we're going to get 6.67 or something like that. 6, right? Repeating decimal. So how many bags of chips can we actually afford? Can we afford 7 bags? Or no. So we can only have, at maximum, no more than 6 bags. Can we buy 5 bags? Is that okay? Sounds good to me. All right. Any questions?